Hello students, welcome to Educate. Today we are going to do some important numericals from work, energy and power chapter. So let's see question number 5.9. Question says a body is initially at rest. So we are doing 5.9. Body is initially at rest. It means u equal to 0. It undergoes one-dimensional motion with constant acceleration. So A is constant. If we apply V equal to U plus AT, we put U equal to 0. So V will be AT. Now, question says the power delivered to it at time t is proportional to. So if you remember, power is F into V. F equal to MA into V. M is constant, A is constant, and V equal to AT. So we write it here, MA into AT, that is MA square T. Here our question says the power delivered to it at time t is proportional to what power of t? These two terms are constant. So we can say P proportional to T. Now, question number 5.10. Question says a body is moving unidirectionally under the influence of a source of constant power. Its displacement in time t is proportional to. So here body is moving unidirectionally under the influence of source of constant power. Its displacement in a time t is given as. So here we write P equal to work upon time, and you know it can be written as P into T. Now work is equal to kinetic energy, so kinetic energy will be equal to P into T, and kinetic energy is half mv square is equal to P into T. It is given that P is constant. Now we write V square equal to, it will become 2P upon M into T, or V equals square root of 2P upon M. Here also there will be square root. So here I am writing it T power half. We can write V as dx upon dt. Here in our question it is given that its displacement in time t is proportional to. So velocity is dx upon dt. If you remember, if you differentiate one times displacement, it gives velocity. So dx upon dt equal to 2p upon m square root into t power half, or dx equal to 2p upon m under root t power half dt. Up to here I think there is no doubt. Now what we can do, we can integrate it. So if we integrate, we write integration dx is equal to root 2p upon m outside the integration symbol, then t power half dt. We assume that distance changes from 0 to x and time changes from 0 to t. If you remember the concept of integration, as I told you earlier, so integration x power n dx gives x power n plus 1 upon n plus 1. So here this will become x. We put the limits 0 to x and 2p upon m under root into power of t will become 3 by 2 divided by 3 by 2. So here other things are constant other than x and t. So this will become upper limit minus lower limit. This will give x, and this can be written as 2 by 3 root of 2p upon m into t power 3 by 2. So here we have to check the dependence of x on t. So we can say x proportional to t power 3 by 2. Now we are going to take next question. Question 5.11. It says a body constrained to move along the z-axis of a coordinate system is subjected to a constant force F given by, we are given F equals minus I cap plus 2j cap plus 3k cap Newton, and where I cap, j cap, k cap are unit vectors along x, y, z axis of the system respectively. What is the work done by this force in moving the body a distance of 4 meter along the z axis? So displacement is along the z axis 4 meter. So 4k cap meter. Now, if you remember, work done is dot product of force and displacement. So here we can write I cap plus 2j cap plus 3k cap dot 4k cap. So if you remember, I dot I is 1, j dot j equal to 1, k dot k equal to 1, rest are 0. So here I times k will give 0, j times k will give 0, but k times k will give 1. So it will be 12 joule. Let's take question number 12. An electron and a proton are detected in a cosmic ray experiment. The first with kinetic energy 10 kilo electron volt and the second with 100 kilo electron volt. Which is faster, the electron or the proton? Obtain the ratio of their speeds. Electronic mass is given this much and protonic mass is given this much, and charge on electron is this much. Sorry, this is in terms of electron volt. 1 electron volt is equal to 1.6 into 10 power minus 19 joule. So here we are given the energies of electron. So let's write it Ke electron divided by Ke proton. So Ke electron is given as kinetic energy 10 kilo electron volt. 10 kilo electron. Kilo means 10 power 3. Electron volt means 1.6 into 10 to the power minus 19. Divided by that of proton, it is 100 kilo electron volt. 1.6 into 10 to the power minus 19. Now, here question is which one is faster. So here these two terms will cancel out. 10 power 3 will cancel out. So 1 by 10 will be left. So Ke electron divided by Ke proton is given as 1 by 10. Now, Ke is also given by half mv square. So, mass of electron into velocity of electron square divided by mass of proton into velocity of proton square. Our concern is to find the speed. So speed can be found by putting the values 1 by 2, 1 by 2 will cancel out mass of proton. So this will become 1 upon 10 into mass of proton divided by mass of electron equal to V electron square divided by V proton square. Now we put values 1 upon 10 mass of proton 1.6 into 10 to the power. In our question it is given 1.67 into 10 power minus 27 kg, 67 10 power minus 27 divided by mass of electron is 9.1 into 10 to the power minus 31 equal to V electron square divided by V proton square. Now it can be simplified. So this will become VE square divided by VP square equals 1.67 in numerator 1.67 and here minus 27 minus 31. So this will give 10 power 4 divided by in denominator 9.1 into 10, so 91. So we can simplify it. So on simplification, we will get around 183. And if we take a square root VE upon VP, then it will be something 13 point around 13.5. So obviously speed of electron is 13.5 times speed of proton. So in our question, our purpose was to find the ratio of their speed. So this much. Now let's take another question. Next question says, a raindrop of radius 2 millimeter falls from a height of 500 meter above the ground. It falls with decreasing acceleration due to viscous resistance of the air until at half its original height. It attains its maximum speed and moves with a constant uniform speed thereafter. What is the work done by the gravitational force on the drop in the first and second half of the journey? What is the work done by the resistive force in the entire journey if its speed on reaching the ground is this? So question is simple. Work done by gravitational force, if you consider half the journey, then only 250 meters should be taken into account. In that case, work done will be mgh. So what is m? In this question, the radius of drop is given as 2 millimeter. So if we find mass by using formula volume into density, so m can be written as m equal to volume into density, and volume is 4 by 3 pi into 2 into 10 to the power minus 3 pi r cube into density of water is 10 power 3. So we will get If we evaluate, so 32 pi by 3 into 10 to the power minus 6 kg. So we have got the value of m. This value we can apply here. So 32 pi divided by 3 into 10 to the power minus 6 into 10 into 250 meter, because half the height. In that case, what do we get? Just see and tell. So 0.182 joule almost. And after that, what can we do? Okay. So suppose work done against gravity or work done by gravitational force here, not against gravity, for entire journey, if we find, that will be double of this, because 250 further we have calculated at 250 meter. Now next 250. So we can just double it, 0.182. So this is work done by gravitational force. Now here object has velocity 10 meter per second square when it reaches the ground. Thank you. Then what happens? We can say that work done by gravity plus work done by resistive force must be equal to gain in kinetic energy. So 1 by 2 mv square, mv square. Here our concern is to get work done by resistive force. So work done by resistive force will be kinetic energy half mv square minus work done by gravitational force. We can put the values here. Mass we have calculated this much, 1 by 2 into 32 pi divided by 3 into 10 power minus 6 into 1, this is 1 by 2 mv square minus 6 into velocity square. So square the velocity, so 10 square minus work done by gravitational force, so twice of 0.182. Now the valuation is left to you. Just try 1 minute, then I will tell. After doing, you will get this value, negative. Now you have to complete it. I'm not doing the calculation. I'm going to next question. Next question says, a molecule in a gas container hits, I'm making it a little bigger. A molecule in a gas container hits a horizontal wall with speed 200 meter per second and angle 30 degree with normal, and rebounds with the same speed. Is momentum conserved in the collision? Is the collision elastic or inelastic? So here, since speed is same after collision, so it is obvious that momentum is conserved. Here this angle is theta, 30 degree. This angle is also 30 degree. Speed is same. It remains 200 meter per second. So if you calculate initial kinetic energy, final kinetic energy, that will also remain same. So you can say momentum is conserved. So if you remember, momentum is conserved in both elastic and inelastic collision. But kinetic energy is conserved only in elastic collision, not in inelastic collision. So here kinetic energy will also not change because component will remain same. Even if two components will get cancelled out, despite that you will get in terms of either cos square theta if you evaluate. So kinetic energy will remain conserved in any case. So you can say that collision is elastic. There is another question. Next question says, a pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cube in 15 minutes. So here volume is given V equal to 30 meter cube. That is 30 into 1000 kg. Time is given as 15 minutes, which can be written as 15 into 60 seconds. Height is given as 40 meter. And the efficiency of pump is 30%. How much electric power is consumed by the pump? If you consider the formula of efficiency, eta is output power divided by input power and eta is given as 30%. And output power we can calculate from here by putting mgh and volume 30 minutes. So this is volume of the tank, and this will become meter cube. This will go 1 meter cube is equal to 1000 liter. So either you just write one here liter first, and since 1 liter equal to 1 kg, so that is why mass has become, because density will be 1000. Density of water is 1000 kg per meter cube. So mass will be 30 followed by 3 more zeros kg. I think you have understood. So we have all information. We can write it like this: 30 by 100 is equal to mgh. M is 30 followed by 3 more zeros into g. So g we can take, like suppose we take 10 unless it is specified. mg, and what is g? G is 10, and what is height? Height is given as 40 meter in our question. So 40 divided by time, we are taking 1 second, or yes, we can take time per second, 1 second, and here you just write input power. Right? Now our concern is to get input power. So input power will be equal to, we just cross multiply. So this will become input power equal to 100 by 30 multiplied by this value. Did I put the value of time? No, 1 second I have, that is mistake. So please correct it. It should be 15 into 900. So now we simplify. 100 into 100 divided by 30 into we are taking this here and this here. So 100 by 30 multiplied by 30,000 multiplied by 10 into 40 divided by 15 into 900. Now we can evaluate it. So it will come out to be 43600, and we are discussing our power, so it will be what? So one mistake I did while taking time, I did not notice, so be careful. Such mistakes should not occur, although question is correct. Later on I have put the value, so that was my fault. So t equal to 15 minute, which can be written as 15 into 60. So after putting that value, we can get correct answer. So you have understood that efficiency is equal to output power divided by input power, and output power can be found by using mgh divided by its. So m is this, g is 10, h is 40, that is given in our question 40 meter, and divided by time is 15 into 60, and then we write the formula for efficiency, and then we can get input power. I think you have understood. Now there is another question. Two identical ball bearings in contact with each other resting on a frictionless table are hit head on by another ball bearing of the same mass moving initially with speed v. If the collision is elastic, which of the following is a possible result after collision? So collision is elastic means what? Momentum will remain conserved whether collision is elastic or inelastic, but kinetic energy will also remain conserved if collision is elastic. So here we have to check whether kinetic energy remains conserved or not. So if mass of these bodies, it's say this is m, this is m, this is m, and here this m, all three bodies has same mass. So in first case, if we consider initial kinetic energy, so these two words here, it's given that two identical ball bearings in contact with each other and resting on a figure. So here velocity is 0, but third body is moving with velocity v. So initial kinetic energy half mv square. Now what is happening here? Second body, this body comes to rest. It means it has no kinetic energy. Now these two bodies are moving with the velocity v by 2. So let's see what is kinetic energy after collision. So 1 by 2 mass of the two bodies. So that will be 2m times velocity square. So velocity is v by 2, so v square by 4. Let's simplify. So what we have got? 1 by 4 mv square. Obviously, energy initial is half mv square, and here final kinetic energy is 1 by 4 mv square. So kinetic energy is not conserved. So first one is inelastic. Now let's take second case. Here initially, so kinetic energy initial value that will remain same as in previous case, 1 by 2 mv square. Now after collision, what is happening? First and second body stops. First and second body stop, and third body starts moving with the same velocity. So in this case, kinetic energy final value will be 1 by 2, single body is moving, so mv square. So here kinetic energy initial and kinetic energy final are equal. It means this is elastic collision. Now consider third case. So for third case, initial kinetic energy, as you know, it will remain same in all three cases. So it is half mv square, and final kinetic energy. All three bodies are moving with velocity v by 3. So let's find out final kinetic energy. So 1 by 2, mass of all three should be taken into consideration. So 3m into velocity squared. So v square upon 9. What do we get? 3 by 9 mv square. So here this will become 1 by 6 mv square. Here again, what you notice, initial kinetic energy and final kinetic energy are not same. So kinetic energy is not conserved. So this collision is inelastic. I think you have understood. Thank you. Team Educate.